I'm Jocelyn Samuel Lucena, also known as Teacher Joffrey. Let's start our lesson for today. Hello guys, our lesson today is calculating the slope and y-intercept of a regression line. Here are our objectives. By the end of this lesson, you are expected to identify the slope and y-intercept from the equation of the regression line, calculate the slope and y-intercept of the regression line, and number 3, formulate the equation of the regression line. Before we start with our lesson, let us review some of the key terms which will be used in this lesson. For the first term, it shows the steepness of a line and represents the rate of change in y as x changes. So you are given this clue. It starts with letter S and it has 5 letters. Okay? Can you answer this? Okay, I guess you have guessed it. The answer is slope. Let's look at the second word. It is a point where the line crosses or intersects the horizontal or vertical axis. It begins with letter I and it has 9 letters. Okay, I guess you have the answer in your thoughts now. Okay, the answer is intercept. Just to have a recall of this term, okay, we have here the Cartesian plane. We have here a Cartesian plane and we have this graph of a line, okay. This point here, the red point, is what you call the x-intercept. It is the point where the graph crosses the x-axis. And you also have here the green point, which is the y-intercept. This is the point where the graph crosses the y-axis. So that's it for your recall. You have our third word. It is a type of regression that finds the best fit line to represent a bivariate data. It starts with letter L and it has 6 letters. I guess this word is also very easy. The answer is linear. Okay, we're talking about linear regression for today. And I think this is not the last word. It is the algebraic expression of a regression line. The algebraic expression of a regression line. It starts with letter E and it has 8 letters. Okay, the answer is equation. Okay, so very good. We now have recalled the 4 words that are important for our discussion for today. Now, what is linear regression? Linear regression is a type of regression that consists of finding the best fitting straight line on a scatter plot of sample data. We have here a Cartesian plane. If we plot the points of our data here, we can see that the dots or the points are actually scattered. Now this red line here is what you call the best fit line. This best fit line, also called the regression line, is used to predict the value of y for a given value of x. The slope and y-intercept of the regression line play an important role in analyzing a set of data. The slope indicates the steepness of a regression line, and the y-intercept indicates the location where it intersects the y-axis. Since we are talking about linear regression, it's good for us to recall the equation of a line. The equation of a line is given by y is equal to mx plus b, wherein your m is the slope of the line. It is also the coefficient of x here, the coefficient of x. And b is the y-intercept, the point where the line intersects the y-axis. And the y-intercept is the value of y when x is equal to 0. Now here is the equation of the regression line as adapted from the equation of a line. This is now read as y hat equals bx plus a, wherein in the same manner, b is the slope of the regression line, and it is also the coefficient of x here. And a is the y-intercept of the regression line. It is the value of y hat when x is equal to 0. In some cases, this regression line is written in this manner here. Y is equal to a plus bx. Now, do not be confused, guys. In some textbooks, talagang nababaliktad po yan, no? As long as your b is the coefficient of x, that is the slope, and the constant, the one which has no x beside it, is what you call the y-intercept. Now, let us identify the slope and y-intercept given a regression line. We have here the first example. We have y hat equals 3x minus 15. Which do you think is the slope of the equation? Remember that the slope is the coefficient of x. Yes, you are correct. The slope is 3. And the y-intercept is the constant. It is negative 15. Do not forget to write the sign of the y-intercept. It's negative 15. Let's look at number 2. Y is equal to, or y hat equals 20.5 minus 12x. As you notice, this equation is like reversed. The y-intercept comes first. This is 20.5. That is the constant. So that's the y-intercept. And your slope automatically is negative 12. And there you have your y-intercept, 20.5. And our third example, y hat equals x over 4 plus 87. What is the slope here? Yes, the slope is 1/4. And the y-intercept is 87. Very good. So how do we calculate the slope and y-intercept of a regression line? To do this, we will be using the formulas. For slope, we have b equals n times the summation of xy minus the summation of x times the summation of y divided by n times the summation of x squared minus the square of the summation of x. For the y-intercept a, the formula is given by the summation of y minus the product of b and the summation of x all over n. To illustrate that, let us look at this example. A teacher believes that excellence is a fruit of hard work and persistence. That's why she wants to prove if the number of students' absences is related to their general average. On her gathered data, the recorded number of absences and general average in the recent semester are shown on the table below. So as you see on the table, we have here 7 pairs of data. The number of absences represented by X here in this column, and the general average represented by Y in this column. So here are the steps now. We have here the example, and let's look at the steps. So for the first one, make a data table for 4 columns. We have X, Y, XY, and X squared. And we have to note the sample size n. So you have there the table at the right. And then we will complete the table. List the data for x and y. So we will copy this from the given example. So we have to write this now in column. So we have there the data taken from the example, written in column now for x and y. We have to take note that n is equal to 7 because we have 7 pairs of data. Okay, so we have the sample size n equals 7. Now to get the entries for x, y column, we multiply the entries in x and y columns. Okay, so we have it here. The x, y column, we multiply the columns for the entries for x and y column. So we have 1 times 98, that is 98. 2 times 90, we have 180. 3 times 86, we have 258. 5 times 87, we have 435. 7 times 85, that is 595. 9 times 85, it's 765. And 10 times 78, that is 780. Now for the x squared column here, we have to square the entries in the x column. So this is the x column, so we have to square the entries here. So 1 squared, or 1 times 1, that is 1. 2 squared, 4. 3 squared, or 3 times 3, it's 9. 5 squared, or 5 times 5, it's 25. 7 squared, or 7 times 7, that is 49. 9 squared is 81. And 10 squared, that is 100. And then the third step, we find the summation of x. We read this as summation of x, summation of y, summation of xy, and summation of x squared by adding the values in each column. So there you have their summation of x, summation of y, summation of xy, and summation of x squared. So we add the entries for each column. For summation of x here, we will add 1 plus 2 plus 3 plus 5 plus 7 plus 9 and plus 10. That will give you 37. For summation of y, we have to add the entries for y column. We have 98 plus 90 plus 86 plus 87 plus 85 plus 85 plus 78. And that is equal to 609. For summation of summation of xy, we have 98 plus 180 plus 258 plus 435 plus 595 plus 765 plus 780. That will give you 3,111. And for the last column, the summation of x squared, we add the entries under x squared. We have 1 plus 4 plus 9 plus 25 plus 49 plus 81 plus 100. That is equal to 269. So from the table, we have n is equal to 7. Summation of x equals 37. Summation of y, that is 609. Summation of xy, 3,111. And summation of x squared, that's 269. For our step 4, we will substitute this to the formulas to solve for the slope and y-intercept. So for the slope, we have this formula, n times summation of xy minus the summation of x times the summation of y all over n times summation of x squared minus the square of the summation of x. Now, I should notice these ones are color-coded, so we can easily substitute the values for each of the symbols that you see here. Okay, so we now substitute. We have n is equal to 7, so you have here 7, and summation of xy, you have 3,111, minus summation of x, which is 37, times summation of y, which is 609, all over 7, which is the value of n, times summation of x squared, which is 269, minus the square of the summation of x, which is 37. Now, applying the mathematical operations, we have here 7 times 3,111, that is 21,777, minus, we copy the sign, 37 times 609, that is 22,533. For the denominator, we have 7 times 269, you have 1,883. And then 37 squared is 1,369. So now 21,777 minus 22,533, that gives you negative 756. And for the denominator, 1,883 minus 1,369, that gives you 514. So dividing this, negative 756 divided by 514, that gives you b is equal to negative 1.47. And this is now our slope. Now we proceed to y-intercept, which is represented by a. We have this formula. A, or the y-intercept, is equal to the summation of y minus b, which is the slope, times the summation of x, all over n. So we substitute the values for this. We have summation of y, which is 609, minus b, which is negative 1.47, times the summation of x, which is 37, all over 7, the value of n. Then applying the mathematical operations, we copy down, bring down 609, and then subtractions. And then negative 1.47 times 37, you have negative 54.39. That's over 7. And then since we have subtraction here and negative here, the rule for subtraction is to change the sign of the subtrahend and proceed to addition. So that will give you now addition. 609 plus 54.39 divided by 7. So there you have 609 plus 54.39 is 663.39 divided by 7. So if we divide this, we will come out with 94.77. Therefore, the y-intercept is A equals 94.77. So now, from our computations, we have the slope, which is represented by B, that's equal to negative 1.47, and the y-intercept, which is A, equals 94.77. For us to get the equation of the linear regression, we will substitute the values of slope, which is B, and y-intercept A to the regression line equation. If you remember, this is the formula for the regression line equation, as we have discussed earlier, y hat equals bx plus a. So as you have noticed, I again have color-coded the slope b here, which is there shaded with yellow, and the y-intercept a, which is shaded with purple. So we substitute the values. We have y hat equals negative 1.47x and plus the y-intercept 94.77. Thus, the equation of the regression line is y hat equals negative 1.47x plus 94.77. So I hope you learned something today. Enjoy and endure. Later on, you will reap the fruit of your labor. So God bless.
This lesson video is based on the Department of Education Senior High School Module for Statistics and Probability, printed by the Department of Education, Region 4A, Calabarzon.